I'm going to highlight about the importance of membrane technology for the treatment of the grey water. When I was preparing these slides about a couple of days back, my younger son who is studying in first standard, he asked me the question, what is this grey water? Just like Professor Satish has mentioned, I don't have any answer. So I just took him to bathroom as well as the kitchen, and I showed him this is actually grey water. Of course, we have different type of the technologies, and particularly for the treatment of the water, even for the desalination, we are talking about the desalination, or it may be the treatment of the wastewater or the sewage water by using membrane technologies. But what I feel was the treatment of the grey water using the membrane, this is one of the most neglected sector, I can say. And as compared to the desalination or any other treatment of the water, the grey water treatment is the most economical and most cheapest. This has been already, it has been proved. Any water which is obtained from the residential apartments or the offices without any toilet water, that is the grey water. What is the grey water treatment? So this is treatment is removal of unwanted suspended material from the grey water collected and disinfecting the same to make it useful for the toilet flushing or the irrigation or for the any washing purposes. So why we reuse grey water? Here the grey water recycling, it can save up to about 35 to 40%. So here what I am going to propose is the membrane bioreactor. This is one of the best method for the economical treatment of the grey water. And of course, this is not a new technology. This has been reported, membrane bioreactor technology. This has been reported sometime during the 1960s itself. However, during that time, initial such experiments were failed mainly because of the severe fouling which was observed in the membranes. And the successfully MBR which was developed sometime during the 90s, and using nowadays in most of the, there are already some commercial units which have came up using this membrane bioreactor for the effective treatment of the grey water. So this is actually the conventional one. This is the second one is the conventional one where the grey water is first, it is subjected to the primary treatment, and then the aeration, and then the secondary sedimentation, and then finally through the sand filtration and the disinfection. So this is actually the conventional method. However, using the membrane technology or using the MBR technology, here up to this one is the common, the primary clarifier. Thereafter, it is subjected to the aeration, and thereafter, finally, after the aeration, the next step is the membrane tank. Here one can use either the microfiltration membrane or the ultrafiltration membrane. And using the ultrafiltration membrane, we can say that up to 99.9% of microbe free, like it may be the bacteria or even the viruses, up to 99.9%, it can be completely freed from the grey water. And suppose if you want the water to be further purified, then definitely one has to go for the reverse osmosis, RO unit. So this is the typical diagram. Here actually this is the bioreactor where the wastewater is fed and the aeration, and then this is for the air outlet, and the water which will be entered in the membranes, or these are the membrane modules, and then finally the treated water. And at the end there is a negative vacuum, has to be a negative pressure which is to be supplied. And basically in the membranes, 4 different types based on the porosity: microfiltration, ultrafiltration, nanofiltration, as well as the reverse osmosis. Mainly as of now in the commercial MBRs, the ultrafiltrations are microfiltration or UF which are recommended because of the very low operating pressure. They can be operated even up to about 2 to 4 bar pressure. The ultrafiltration such units could be handled. And mainly in the membranes, 2 types. Again, one is the flat sheet membranes, and this is actually these are the flat sheet membranes like a normal any sheet. And these are the hollow fiber membranes. These are actually the advanced type. In the last 10 years, hollow fiber membranes are becoming more and more popular because of the larger surface area, and also due to the cross flow filtration, the fouling is also very, very less in this hollow fiber type of the units. This is actually a typical filter which is made up of flat sheet membranes. And this is actually the immersed membrane, particularly this is a single fiber. This is single hollow fiber. So a large number of, say some hundreds or thousands of hollow fiber membranes which makes the cartridge. And those cartridges which are directly submerged in the aerated Greywater. And this is actually this system is working on the into out. So this is the working methodology here is into out. That means once this membrane, single membrane, once it is immersed completely in the water, the aerated water, the water molecule which enters into this membrane in a single hollow fiber, and then the permeate which will be collected on the other side. So here up to 99.9% microbes could be completely, they can be removed. And here, of course, these are the other setups which are required here. The aeration. Aeration mainly needed for supplying the oxygen for the microorganism, and also for degradation and degradation of the different chemicals which are present there. And another one of the major problem which is faced in the membranes is fouling. So after using for a particular time duration, the fine pores which are present in the membrane, they get severely affected by the different type of it may be microorganisms or any sort of the impurities, which is nothing but the fouling, and the efficiency of the membranes will drastically come down. So here the role of material scientist is very, very important in order to come out with membranes with the highly anti-fouling type of materials. And my research group is, we are developing on the anti-fouling materials for the membranes. And already we have developed a very small, a small working prototype of using hollow fiber unit. And I hope to come out with a larger prototype related to the MBR, which was indigenously developed in our laboratory. And this is just some couple of material which I'm going to present, which reported from our group. And these are highly anti-fouling in nature. This is actually, we have used the halloysite nanotubes on which the polydopamine which was coated, and then this material, because of the super hydrophilic nature, acts as a anti-fouling. Of course, this is the chemistry. I don't want to go due to the lack of time. And of course, these material are also found to be highly antimicrobial in nature. And this is another material. This is also indigenously developed from our group itself. This is the last slide, which was taken in the Dead Sea of Israel. And thanks to Professor Pradeep and the IIT Madras for giving me this wonderful opportunity. And this is my proud privilege to have to receive this award from the Honorable Chief Minister of Karnataka, as well as Professor Rao during August 6th, 2018. Thank you very much.
Thank you. Thank you very much, Arun.